in this problem, we need to find the angular velocity of the rod and the velocity of its mass center in the three given conditions. So for letter A, after it strikes point A, for letter B, after it strikes point B, and for letter C, after it strikes point A for the second time. So let's start first with letter A. So I have here a sketch of the scenario. So the rod with mass M strikes point A with a velocity v1, causing an impulse at point A and causing it to rotate with angular velocity omega 2. So the mass center of the rod also moves with velocity v2. Now, so when the rod hits point A, it bounces off and moves upward with velocity va2. Now, since the impact is elastic, so our coefficient of restitution is equal to 1. Therefore, so we say that va2 is equal to v1, so directed upward. So since the center of the rod is at a distance L over 2 away, and because V2 is in the opposite direction of VA2, the equation for V2 would be, so V2 equals, so L over 2 omega 2 minus VA2. So this would be equal to, so L over 2 omega 2 minus V1. Now, taking the moments about point A and taking the clockwise direction as positive, so we'll have, so M V1 L over 2 plus 0 equals M V2 L over 2 plus I omega 2. So, since this is a rod, so the equation for its moment of inertia is 1 over 12 m L squared. So, substituting this and the equation for V2, so our equation would be, so M V1, so L over 2 equals, so M times L over 2 omega 2 minus V1 times L over 2 plus 1/2 M L squared omega 2. So, simplifying the equation, so it would be, so M V1 L over 2 equals M L squared over 4 omega 2 minus M V1 L over 2 plus 1 over 12 M L squared omega 2. So, further simplifying the equation, so this becomes, so 2 M V1 L over 2 equals 4 over 12 M L squared omega 2. So omega 2 is equal to 2M V1 L over 2 times the reciprocal of the right hand side, so 12 over 4 ml squared. So this would be equal to 3 V1 over L. So clockwise, in the clockwise direction. Now, solving for V2, since we now have omega 2, so V2 is equal to, from the equation earlier, L over 2 omega 2 minus V1. So, this would be L over 2 times 3V1 over L minus V1. So, this would cancel out. So, that's 3 halves V1 minus V1. So, that would be equal to 1/2 V1. So, directed downward. Now, when the rod bounces off point A, the other end strikes point B with the velocity VB2 directed downward. So, this velocity is equal to VB2 equals, so L omega sub 2, because point B is at a distance of L away from A, then minus VA2. So this is equal to L times 3 V1 over L minus V1. So this is 3 V1 minus V1. So that's 2 V1 directed downward. So we will use this for letter B. So letter B, so we'll now focus on the impact at point B. So when the rod strikes point B. So I have here a sketch of that scenario. So the rod, which is now rotating at an angular velocity omega 2 and whose mass center is moving at V2, strikes point B with a velocity VB2. So this produces an impulse at point B. So the impact causes the rod to rotate with an angular velocity omega 3, and its mass center now moves with a velocity v3. So when the rod hits point B, so it will bounce off and move upward with a velocity vb3. And again, since our E is equal to 1, so vb3 is just equal to vb2, but in the opposite direction. So that would be 2v1 upward. Now, since the center of the rod is at a distance L over 2 away and v3 is in the opposite direction as vb2, the kinematics equation for v3 is, so v3 equals, so vb2 minus L over 2 omega 3 equals, so that will be equal to 2v1 L over 2 omega 3. So now, taking the moments about point B, so taking the clockwise direction as positive, so we'll have, so negative m v2 L over 2 plus I omega 2 plus 0 equals m v3 L over 2 minus I omega 3. So substituting the values that we have, so this becomes, so negative m times 1/2 v1 times L over 2 plus, so that's 1 over 12 ml squared times 3 v1 over L equals, so m times 2 v1 minus L over 2 omega 3 times L over 2 minus 1 over 12 ml squared omega 3. So, simplifying the equation and joining the like terms on one side of the equation, so this becomes, so minus or negative m v1 L over 4 plus ml v1 over 4 equals ml v1 minus ml squared omega 3 over 4 minus 1 over 12 ml squared omega 3. Okay, so the left hand side would be 0 actually. So we can transpose mlv or the terms with omega 3 on the other side. So it will, and combine them. So our equation would become, so ml squared omega 3 over 3 over 3 equals mlv1. So, from here, we can get omega 3. So, omega 3 is equal to mlv1 times the reciprocal. So, 3 over ml squared. So, that would be equal to, again, 3v1l. So, in the counterclockwise direction. Now, solving for V3, so V3 is equal to, so 2V1 minus L over 2 omega 3. So that would be 2V1 minus L over 2 times 3V1 over L. So that would be, so 2V1 minus T halves V1. So that would be, again, equal to 1/2 V1. So, directed upward. Now, when the rod bounces off point B, the other end strikes point A again for the second time with a velocity VA3 directed downward. So, this velocity is equal to, so VA3 equals, so L omega 3 minus VB3. So, that would be equal to L times 3V1 over L minus 2V1. So, that's 3V1 minus 2V1 is equal to V1. So, directed downward. So, we will use this later on for part C. So, for letter C, we'll focus on the second impact at point A. So, I have here, again, a sketch of the scenario, that particular part of the problem. So, the rod, which is now rotating at angular velocity omega 3 and whose mass center is now moving at V3, strikes point A again with a velocity VA3. So, this produces an impulse at point A. Then, the impact causes the rod to rotate with an angular velocity omega 4 and its mass center now moves with a velocity V4. So, when the rod hits point A, it bounces off and moves upward with a velocity VA4. And since, again, E is equal to 1, our coefficient of restitution is equal to 1, so VA4 is equal to VA3. So, which is V1 directed upward. So, since the center of the rod is at a distance L over 2 away, and because V4 is in the same direction as VA4, the equation for V4 would be, so V4 equals, so VA4 plus L over 2 omega 4. So, this would be equal to, so V1 plus L over 2 omega 4. So, now, solving for the moments about point A and taking the counterclockwise direction as positive. So, we'll have, so M V3 L over 2 plus I omega 3 plus 0 equals, so M V4 L over 2 plus I omega 4. So, substituting the values that we have, so this becomes, so M times 1/2 V1 times L over 2 plus 1 over 12 ml squared times 3V1 over L. So, equals, so M times V1 plus L over 2 omega sub 4 times L over 2 plus 1 over 12 ml squared omega 4. So, simplifying the equation, so this will become, so M V1L over 4 plus M V1L over 4. So, equals, so m v1l over 2 plus ml squared omega 4 over 4 plus ml squared omega 4 over 12. So, combining like terms on one side, so we'll have, so m v1l over 4 plus m v1l over 4 minus m v1l over 2 equals, so m l squared omega 4 over 4 plus ml squared omega 4 over 12. So, the left-hand side will be equal to 0. Hence, so this tells us that omega 4 is equal to 0. And then, lastly, solving for V4. So, V4 is equal to V1. Then, the second term would be 0. So, V4 is equal to V1. Directed upward.